Okay, so in this section, we're going to have discuss the errors with hypothesis testing. So there could be some error in our testing, and we just need to be careful when we're doing the process of hypothesis testing. We could have 4 different scenarios, and 2 of these scenarios are the type 1 and type 2 errors, respectively. Okay, so the first one is if we reject the null when the alternative is true, right? So yeah, if we reject, then we would accept the alternative. That's okay, right? Check mark. If we do not reject the null when the null hypothesis is true, so we do not reject it, and that means that we would just support it, right? Like there's no change, right? This is correct, right? We don't reject it. That means we accept it. Boom, outcome 2, that's correct. Outcome 3 is actually when we reject the null, right? Here's the null. We reject the null when the null is true. We can't reject it if it's supported, right? This is the error. This is a type 1 error. And we call the type 1 error to be alpha. Go, right? Like Family Feud. So the next one is do not reject the null when the alternative is true. So here's the null, here's the alternative. So you do not reject the null when the alternative is true. Wait, you can't accept both. There's either been a change or there hasn't been, right? So something's wrong here, and this is called a type 2 error, right? And we call this one beta. Okay, so I put a little table here, kind of like how it looks like as a matrix. So here's the reality. The reality is the null is supported or the alternative is supported. The conclusion we get from our hypothesis testing, because that's where the error comes from, right, is if we do not reject the null and the null is true, okay, that's totally okay, right? But if we do not reject the null, that means we accept the null when we should have accepted the alternative. That's the type 2, right? That's outcome 4. Rejecting the null when the null is true, that's the type 1 error. So that's the alpha, this is the beta. And when we reject the null and we accept the alternative, that's correct, right? That's what we wanted. So this was outcome 1, and this is outcome 2, and those were correct. Okay, so that's the idea, is we want to make sure that if we do not have enough evidence to support the alternative, then we do not reject the null. And if we have enough evidence to reject the null, and then we accept the alternative. Okay, and we're going to do more of these, a lot of them, for the rest of the semester. Okay, so I just want to make a note that when we say true, false, it's not really mean true. We just say that to be short. But as statisticians, we know that it's just saying that we have enough evidence to support blah. Okay, so let's look at this short example. That it is believed that 11% of all Americans are left-handed. A college needs to know how many left-handed desks to place in the big lecture halls being constructed on its campus. And a random sample of 140 students from that college, whether or not the student was left-handed, was recorded for each student. The college wants to know if the data provides enough evidence to show that students at this college have a lower percentage of left-handers than the general American population. State the random variable, the population parameter, and the hypotheses. State type 1 and type 2 errors in the context of this problem. So let's go ahead and just do one by one. I think that's the easiest thing to do. So the first one would be stating the random variable. And I think we can see what the random variable here is, right? Notice they gave us a percentage. They didn't mention the mean, and they didn't mention the standard deviation. And right away, we see a percentage we say, oh, you know what? This is going to be a proportion problem. So we do know that the random variable is the percentage. Let's see. 1 second. Okay. The random variable is defined as the percentage of left-hand students. From the sample. Okay, right, that's like our x. I guess I can put like a capital X equals, right? The second 2i is the population parameter. So the population parameter gives us a proportion, so a p, which they define as 11%, right? Or we usually write 0.11. Okay, and then the third part, 3i, would be the hypotheses. So the hypotheses, when we're actually given a specific parameter, in this case it's going to be a proportion, then we write it out like that. So we just go ahead and write it out as the null is status quo. That means the population proportion hasn't changed. Right? No change, status quo. The alternative is saying that, and then this is where we kind of need to go back to our problem. It says blah, 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 right? And then the college wants to know if the data provide enough evidence to show that the students at this college have a lower percentage of left-handers than the American population. So the lower percentage. So what does lower mean? Does that mean greater than or less than, right? Well, lower means less than, right? And means left-tailed. So we know that it's going to be a less than symbol, and we write p, the parameter symbol, and then less than this 11%. So we use the population parameter given for both the null and alternative, and the only thing that really looks different, if I can point out, is that one's the null and one's the alternative, and equals and a symbol. But other than that, the p's and the h's, the colon, and the actual population parameter never changes. It's just what we're identifying to be the null in the claim. Okay. Now the last part is actually identifying the errors, right? So let's go ahead and let's first look at a type 1 error. Okay, so the type 1 error, recall, it says up here, let's look at our table. It says a type 1 error is when we reject the null when the null is true. So we reject the null when the null is true. Okay, so the null is that there was no change, right? So this means that if we interpret it, the percentage of left-handed Americans is 11% when we concluded it was less than 11%. And so the college would have probably just used the 11% to buy the desk, and they may have, because we concluded that it was less than 11%, they may have shorthanded the number of left-handed desks they needed to buy, and now there's students without a left-handed desk that are actually left-handed, right? So if we looked at a type 2 error, let's go up there and identify from the table. A type 2 error says that we do not reject the null when the null is we do not reject the null when the alternative is true. So here, we do not reject the null when the alternative is true. Okay, so this means that the percentage of left-handed Americans is less than 11% when we concluded, because we didn't reject the null, right? When we concluded that it remained to be 11%. So here, we concluded that it remained to be 11%. So that means the college made the error that it was 11%. So now they over-purchased left-handed desks because it really meant that we made the error, a type 2 error that stated that it would have been less than 11% of students would have been left-handed at their institution. So that means that because we made the mistake that we concluded it remained the same, we over-purchased left-handed desk, and now we have a surplus, which is over budget, and now that money could have been used elsewhere for other resources. So, it seems simple, but in a big university like UCLA, 11% could be like 10,000 desks. So if they only needed 5,000, that's a lot of money that they over-purchased. So it's really important we don't make these type 1, type 2 errors, because something as simple as purchasing desks all the way to people contracting a disease or a virus, like these statistics are really important to be careful with so we make meaningful statistical conclusions that are valid. We would hate something to be invalid, like the AT&T lowest drop calls data, right? Okay, so putting this all together, I put it in a little box, right? So the probability of making a type 1 error. So there's a type 1 error when we reject the null when it's true. The probability of making that error is alpha. Okay, so the probability of making the type 2 error, which is beta, is when we do not reject the null when we should have, right? So the probability of us making this error is beta. So the probability of making a type 1 error, alpha, is chosen by the researcher before we even begin. It's called the level of significance. And as the probability of the type 1 error increases, so as this error increases in probability, the type 2 error decreases and vice versa. So as alpha, this probability alpha goes up, beta goes down. Or as alpha decreases, the smaller the alpha, the bigger the beta. So this is the first scenario. The second scenario. In our class, in this class, we're going to go ahead and mostly use alpha. We won't use beta. You will see beta again in probably your future statistics courses, like research methods, but here we only are going to use alpha, which is nice, and we are given that, and if we're not given that, then we assume a certain level of significance. Okay,